My tomorrow task for you is just you have to construct a 4-layer board, sorry, a 6-layer board, an 8-layer board, and 10-layer board. Okay, and then you have to use blind via and buried via like this. You have to create and you have to send the samples for to me in group so that I can check and check and suggest if anything wrong. Okay, so this we have done blind via for 4 layer I am doing. Okay, now coming to the blind via, buried via. Okay, so here blind via. Okay, so here blind via is in 4 layer we have only one type of via. Okay, first is VIA. Okay, via and dash. So it connects only layer 2 to layer 2 to layer 3. That's all. For 4 layer, only one via definition is there. This
Sir,
4
it is
definition you
buried
understand?
via.
Ah, buried via. Yes. Sorry. This is buried via, no? Buried via. That's buried via. That is buried via. So in third definition you see here. Via definition telling via L to L2 means via, this is buried via. So by name itself you will come to know which one can be buried, which one will be blind. Okay, understood my point? Hello? Hello everyone.
Yes, sir.
Yes, sir.
So this via tomorrow I need 6-layer board and sorry 6, 8 and 10-layer board. Just draw a graph like this and show me and the via definition. Definition means via it will be layer 1 to layer 2, layer 2 to layer 3, layer 4 to layer 5 means how we can construct the via because same thing we are how the definition we have given via L2 L2. Same thing we are going to implement in our advanced things, our advanced designs. Okay, same thing we are going to implement. So this will be there like this. Okay. Okay, so for 4-layer board, 4 types of blind via can be used and only one type of buried via can be used. Okay, in 4-layer board, they will ask in 4-layer board, okay, how many types of blind via can be used? How many definitions? How many definitions can be used? You should reply for 4-layer boards, 4 kinds of blind vias can be utilized and one kind of buried via can be utilized. I will ask why, how, can you show? So you have to draw and show them. Okay, understood? Now come to the via structure. Next is via structure. Via structure. Okay. So I told you via is nothing but a through hole peri-stack. Okay. So how the through hole peri-stack will be? There is some specific rule for the via. Okay. The via structure we are discussing here. So this is our copper. Red one is our copper. Okay. Copper. Copper. And this black one is drip. This is copper and this is drill. Okay, via. So the via rule is, just keep in mind. Okay, the via rule is the area of copper will be just double of drill dia. Okay, area of copper, okay, will be just double of drill dia. Understood, guys? Suppose 1 mm drill is there, then the pad stack, the regular pad you can see here. This is not regular. You can't see here pad. You can see here copper annular ring. Okay, so the area of copper will be just double of the drill dia. Okay, here rule is via rule, you can say. Via construction. Construction. Okay. Okay. Copper area. It is called what? ENNU LAR, annular ring. Just double of just double of what? Drill dia. Okay. Guys, clear? Means suppose drill equals to 1 mm, then angular ring will be 2 mm. Okay, that's clear. Suppose second example 2, drill is 10 mil, then another ring will be 20 mils. Okay, and name of the via would be like this, via, and unit always use unit should be in mil. Okay, because mil will give you a better understanding in mils. Okay, so we have vias like, suppose here, so suppose that we are giving the via name is via 10 20. That means what? Can anybody tell me? Guys, you have gone through the my website, no? That blog. Have you gone through that?
Yes, sir.
Nobody is telling. So that idea will be having, no. So why are you not telling? Say something. By 10 20 means what?
10 mil hole and 20 mil annular.
Yes. Drill equals to 10
10.
mil. Okay, and
Copper.
drill. Sorry,
Miller.
drill
20.
20 mil. Okay, 10 20. Okay, so we have via. So first I'm telling about first what we are using for the PCBs. Okay, first we are using it via 8. Okay, 16 0 1 6. That means, see, suppose we are using for signal tracks, guys. Suppose you are using signal tracks. Okay, hello,
Yes, sir.
or leave it. No, via 10 20 you can use 10 20. Just start from 10 20. Later will, if you have some ideas, then we'll see later. 10 20. 10 20 use means 10 mil drill, 20 mil angular ring. Okay, that this size is used to this size is used for general signals. Okay, general signals we having current and voltage in milliamps, millivolt. Okay, so via 1020 we are using for general signal. Okay, guys, again another via we have via 1224. This is also using for what? General signal only. Okay, now another one we have third one via 1428. This can be used for power and ground signals. Power and ground signals.
Ground.
Okay, guys, power and ground signals. Right? Again, fourth one is coming via 16. Then space will not be there. Okay, keep in mind space will be not there. You should not maintain the space. Via 16 32.
32.
Okay, and one more via is you have fifth one via 20 40. Suppose you have a heavy current to pass. Okay, heavy current pass, so that you can use this. So via 10 20 20 24 you can use for general signals. Rest via can be used for what? Power and ground signals. Okay, that depends on what? What is that depends? It depends on your current of the signal of the power and ground signal. Understood? Guys, clear? Okay. And anybody After this, can anybody share their screen so that we can continue the last board we have done in both by. Guys, is it clear? In this, anything need to be discussed in this? Hello? Hello?
Yes, sir.
Guys, why are you not speaking here? In this, anything need to be discussed?
No, sir.
Okay. Now we are moving for next topic is fiduciaries. Okay, fiduciaries. So fiduciary is nothing but just bare copper of area. Okay, sorry, bare area of copper. Okay, that is just a reference point to map or to snap our PCBs or our motherboard for the printings and for other process. Printing means I mean the solder paste printing. Okay, so that is nothing but reference point. Suppose you have a PCB, you have a PCB, so that reference point we have to see. Suppose this is the PCB, big much this one bigger PCB is there, and inside that so many through hole and assembly components will be there, right? So assembly components will be placed or through hole component will be placed through the automatic machines. Okay, so automatic machines required some reference point to be picked. Okay, hello.
Yes, sir.
Hello, guys. One game I want to discuss. There is a game, shooting game. Okay, shooting game. Have you seen like gun shooting? People are taking the gun, and they are taking some time to map their destination, to point their destination. Okay, once the destination locked in their eyes, then they will fire. Guys, understand my point? Without locking, without zooming that and without knowing that the destination, will they fire? Hello, guys, have you seen the shooting game?
No, sir, no.
First, they have to measure their aim. Okay, they will take some time. They will concentrate their eyes, and then they will fire. Means that is measuring their aim, right? And without measuring, if they fire, their their bullets will go somewhere, and the aim will be somewhere else, right? Okay, so if you have seen the automatic printing machines or assembly machines, so you will be required. That is, so you will be required some reference point to be measured, right? If you see here, if measure point means we need some reference point to be measured. Suppose here you get. So this will be raw point, and this will be another point. This is other point. So what they will do? Their machines, the printing machines, as well as their assembly machines, they will measure the points. They will measure the points exact. At least three reference point they need. Okay. So what we are discussing here? Fiducials. I mean to say fiducials. Fiducials, right? So if you see here, this is the one for one PCB. At least, at least there is a three fiducial points required to measure precisely. They don't want to waste their aim. If this reference point will be not there in the PCB, then they can't measure it and they can't place a symbol at all. Okay, I mean to say here, if I show you, so if I show you some example of the potentials, so I have already seen some data. Have you gone through it? No. Okay. You see these boards, these motherboards. Okay, I'll show you some big points. If you see here, this is local position. I'll come to later on this. Let me show you some big boards. Yes, this is the best example I can say. But this is small picture. I can't explain. I want to show some big picture. Hello.
Is it right time to talk?
Just now I'm having some classes. I'll be back within 5 to 10 minutes. Okay.
Okay, sir. Okay. Okay.
Yes. Suppose this is the board I'm packing. Okay. Okay. You see here, there is just some point. This is the one. Okay. This is the point. Fiduciaries. Okay. So what they will do? They will map exact with their machines, and then they will place these components. They can place. What is the importance of it? I'll tell you. So for one PCB, at least minimum three required. The three reference points, three producers required. Minimum three. Okay. Maximum four. But minimum. Okay. So if you see here how show some videos visuals how they are using. So if you show there this one, show that they will use laser, okay, and they will map that. Not from the SMT pick and place. Just see this. Guys, see here. This is a scanner. Can you see this? Okay. This is a scanner. They will scan their reference points, fiducials. See, this is a camera. Guys, you see this camera? Can you see? This is a scanner. Okay. Hello.
Yes, sir. Yes.
So with the help of this scanner, they will measure, they will mark these three, they are fiducials. Okay, and that same positions, the pick and place machine will pick the PCB, whole PCB, and keep in their machine automatically. Okay. So I mean to say this is the pick and place. So this is the reference point. So what they will do, they will pick this and they will keep inside the machine. Okay. Why? Because this reference point they need to pick the components and place it. So from this reference point, they will measure their distance. Means the machine itself, their computer itself, they will measure and keep that. Okay. Now, types of fiducials. Fiducials. First is coming in the picture is global fiducial. Global fiducial. Second one is local fiducial. Local fiducial. Global means full PCBs. You see here the fiducial which is used for the full PCBs. Okay, so this is the type of global fiducial. This 4 is type of global fiducial. This all is the type of global fiducial. Okay, global fiducials used for whole PCB. Okay, why? Because pick and place machine solder testing has to be done. So they will simply pick at the reference point, and with the measurement of the reference point, they will place the components and they will start the next processes. So this is called global fiducial, right? So it will be for whole PCBs. Guys, clear? Now, local fiducials. Local fiducials used for the fine pitch components. Fine pitch component means the components which is having less than 0.5 mm pitch. That comes under the fine pitch components. Okay, and that fine pitch components is very smaller and very small pads stacks will be there. Okay, so it is highly possible so that during the assembling, during the testing, and during the soldering, that can shake, that can that can shake and that can sort their pads, because the sizes of pads and pins are very smaller. Okay, if you see here. Okay, so for one point, for components, take this PCB. They will ask in interview, what is the fiducials and why we use that. So tell him in the assembly process, we need exact size, exact PCB measurements, okay, to take the reference point for the placement of the components. Which placements? Assembly placements, not us. Because in assembly placements, that is done by the machines, and that machines required at least three reference points to be measured. Okay, so here if you see, I told you global fiducial for whole PCB. Okay, global PCB for whole PCB. You see here, this is this. Okay, this. Okay, this is two PCBs here. Okay, this is some different PCB. This is some different PCB. This all is what is used for the whole PCB. That is called global PCB, global fiducial. Okay, and what is used for the components, fine pitch components, CD. See this. This all is local fiducial. Local fiducial is used for a particular components, fine pitch components, small components, because they need to be placed precisely with the help of VGA machines or pick and place machines, because their pads are very smaller, and it is a possibility, highly possibility will be there to sort their pads and connections, right? So in that case, they are providing local fiducials. Local fiducials. Okay, why? Because they will place the component for full PCB. For 5 pin component placement will be done by some different machine, some different precise machines. Guys, getting my point? So to place the particular this fine pitch components, they need extra machine. Okay, so for that machine, they need to measure this to place precisely. You see here three fiducials are there, right? So local fiducials can be two. Local fiducials can be 2 or 3, not 4. Global fiducials can be 4 or 3, as per your locations and depends on your locations and areas. Right, clear?
Yes, sir.
Any doubt you have?
No,
If you
no,
have
sir.
to discuss something, please let us know. Girish? Girish,
Yes, sir. Yes, sir.
any doubt you have?
No, sir.
Let me check who else are there. Bhagya, how about you, man? Bhagya? Gopinath, any doubt? Hello?
No, sir, no doubt. Everything's
No
clear.
doubt, sir. No doubt, sir.
Maniraju?
No, sir.
Parveen? Parveen?
No, sir. No, sir.
I have shared one link for the fiducials, that also you can, through that you can take a note. Okay, and this,
Okay, sir.
Yes, sir.
okay, so
Okay,
this is the fiducial, this is the fiducials and vias. Okay, next is we are going to discuss about the layer stack up. Guys, this link is going to expire in 5 minutes, so layer stack up will take a bit more time. Okay, so I am sharing the new link again.